Okay, so let's say that we have an object that's moving in 2 dimensions in the xy plane, and it has an acceleration in the horizontal or x direction, which is b times t, where b is some positive number. So the acceleration is changing with time, and it has in the y direction, let's say that's the vertical direction, so the acceleration is just the acceleration due to gravity. So let's say we want to find the object's position, right? So the position is a vector, right? So the position is a vector with an x component, so we need some quantity written like this, where we have some x component and y component, and the question is, what are the x and y values as a function of time? We could find the position at a specific time, so we need to know what x and y are. Okay, so this is nothing more than the kinematic equations. Let's start with, let's have ay equals minus g, and to parallel that for the x direction, we have ax equals b times t. The vy equation, now we integrate this, and of course we get a constant of integration. Let's call it v naught y, because it's the y, it's the initial speed in the y direction, minus g times t. And when we integrate that to get the y position, we have to add an additional constant of integration, y naught plus v naught y times t minus 1/2 gt squared. We already saw this. We're familiar with this. Things are a little bit different in the horizontal direction. We have a vx, the velocity in the x direction, which is the integral of this. We have a constant of integration, which is similar to this in spirit, because this value could be different from that, but we have a constant of integration, plus we integrate this, we have b t squared over 2. So that the velocity in the x direction is increasing in time at a rate of t squared, and then we integrate to get the position. We have the usual constant of integration, which brings in the x naught, plus v naught x t, plus, we have to integrate this. The integral of t squared in time is t cubed over 3, so we get a t cubed over 6 there, and these are the kinematic equations for the object. And so the position is given by x, this equation as a function of time, I hat plus this j hat. So notice that the sort of laws that we've derived, these kinematic equations, aren't enough to specify the behavior of this object. We have to also give values to v naught x, v naught y, y naught, and x naught. In other words, we have to specify things. We have to give conditions at certain times, and in this case, these times correspond to t equals 0, because at t equals 0, this becomes that, this becomes that, this becomes that, and this becomes that, right? So let's write our r vector. That is going to be an x naught plus v naught xt plus b t cubed over 6 I hat plus y naught plus v naught yt minus 1/2 gt squared j hat. And so let's say that we specify particle starts, meaning at t equals 0, starts at rest at the origin of an xy coordinate system, what does that mean for the subsequent position, or the position vector of the object? Right, starting at rest means that this is 0 and this is 0. Starting at the origin means that this is 0 and this is 0. So this becomes bt cubed over 6 I hat minus 1/2 gt squared j hat. So that is the position vector as a function of time. And let's say we want to know the position at t equals 2. At t equals 2, we have that the position of the object is 2 times 2 is 4, times 2 is 8, so we have 8/6, which is 4/3 b I hat, minus, we put t into here, we square, we get 4 divided by 2, we get 2, minus 2g j hat. So if we were to plot this, let's see, 4/3 b, right, it's a little bit larger than b. Let's say that b is somewhere like that. Then we are somewhere over here, a little bit larger than b in the x direction. This is x, and this is y. Minus 2g, let's say g is there, right? It's like minus 10, and so we have minus 2g, which is like minus 20 if we're dealing with meters per second squared. The 2 obviously has dimensions, and b has dimensions such that we're dealing with distances here. So we would be somewhere over here. And here is our vector at t equals 2 seconds.